Let's consider this connected masses question. Here we have frictionless pulley, okay, and a frictionless bench top. We have two masses connected by a string, and the string is weightless. M1 and M2. M1 is 5 kilograms, M2 is 1 kilogram. Okay, how do we start to do this problem? Now, well, I guess what's the question? So we're going to try and find out. We're trying to find the acceleration of both masses, and B, we're going to try and find the tension in the string. So where do we start? Well, we start by considering the system as a whole. If we're trying to find the acceleration, we have to recognise that these two masses are connected together and they're going to accelerate together. So we consider it as a combined system. If we want to do that, then we have to think about, well, okay, what are the forces acting on the system? Now, both of these masses have gravity acting on them, but for mass 1 here, it's also going to have the normal reaction force, which is going to cancel out gravity. So the only force that's left over is the force of gravity on this mass here. So that's going to be the net force on the system. F net equals M2G equals 1 times 10 equals 10. Okay, newtons. Now for we found the net force on the system. We can just go to our Newton's second law. F equals ma, well, that's the net force. F net equals ma. So we found the net force here. 10 equals ma. Now, what are we going to use for the mass? Well, this force is accelerating both of these masses, so we have to use the combined mass. Equals 6 times A. 5 plus 1 is 6. So acceleration, just simply rearranging, equals 10 over 6 equals 1.66 if you calculate that in your calculator. Actually 1.67, I should round that up correctly. Meters per second squared. Cool, well that's easy enough. What about the tension in the string? Now this is slightly more complicated. The string is within the system, okay? So we go from considering the system as a whole to considering an individual mass and the forces acting on that, okay? If we look at M2, we can say, well, right, what are the forces acting on this? Well, there's going to be a force of gravity pulling it down, but there's also going to be some tension pulling it back up again, okay? And those two forces add together to create the net force on that mass. What's the net force on that mass? Well, it's not the same as the net force on the system, okay? That's an important distinction to make. The net force on the mass we can find from the acceleration of that mass, which is the same as the acceleration of the entire system, and the mass of that mass. Okay, so the F net on mass 2 equals M2A equals 1. The mass of mass 2, 1 times 1.67 equals 1.67. That's the net force on that mass. Now, from that net force, can we find the tension? Well, we know that the net force, F net, equals the sum of these two forces, but they're in opposite directions. So it's equal to mg minus the tension, okay? Because t is in the opposite direction, we give it a negative sign. And we found F net over here. We know the mass, we know gravity, and we're trying to find tension. We can rearrange very simply by moving tension to the other side and moving F net back to that side, and we get tension equals mg minus F net. Okay, and that is equal to 1 times 10, that's the force of gravity on this, minus the net force, which is 1.67. So we just end up with 10 minus 1.67. Okay, equals 8.33 newtons. So that's the tension in the string. Okay, this mass has 10 newtons pulling it down, 8.33 newtons of tension pulling it back up, and those two combine to make the net force of 1.67 newtons right there. So for the acceleration of both masses, consider the system as a whole. For the tension, which is internal to the system, we have to consider the masses individually.